And let me share my screen and then we can start. All right, I think you should be looking at my presentation right now. Oh, my bad. Slideshow. Looks good so far?
Yes, we can see.
Perfect. All right, so first of all, actually, thanks everyone for being here. This is a very special topic for us, for Dizet and myself, and hopefully we can just share some insights and things about what this means in the industry. To start, just a little bit about us. We're both machine learning engineers here at Factor. We've been here for, I think, almost 2 years, a bit more than that. And we're just going to be presenting some of the topics and things we prepare for you. So this is the agenda. This is the proposed one. First, we're going to talk a bit about what's actually MLOps for us. What do we think about this as an end-to-end lifecycle? Then we're going to show you some Factor use cases we have about MLOps. Then we're going to talk about the principles and some initial considerations that we should have when we're discussing and talking about MLOps. And finally, the last section. So what's MLOps then? What's the role looking like? And what is the industry looking for when we talk about MLOps engineers? And then just the section for questions and answers. So thanks a lot for everyone to be here, and let's start.
Okay, thank you so much for being here to everyone. We appreciate your time and your motivation to continue learning and also your curiosity. These are the most important skills in this rapidly changing technology and environment world. In particular, we know how much learning is changing and shaping many industries. But as the demand of ML model increases, so does the challenge to maintain the machine learning models in a production environment. So that's where MLOps comes in. MLOps is the practice of combining the two practices of software engineer and DevOps engineer for machine learning products to improve the speed, the quality, and the reliability of the models. As someone interested in ML, it's important to understand MLOps because it affects every stage of the ML cycle, from data preparation to model deployment and monitoring. It is very, very essential for ensuring the success of a machine learning project. So ignoring MLOps can lead to suboptimal models, increase the downtime, and also decrease the efficiency of the models and also the team in the team environment. So let's dive into the ML lifecycle. If you understand the different phases involved in your ML project, you can create as is state and also the to be state. So you can identify potential pain points, and opportunities for improvement. That design more effective ML pipelines and implement better processes for monitoring and maintaining the ML models in production. We grouped the complete life cycle in 5 phases. Our first phase is the scoping phase. First, we need to identify the business problem we want to solve and a specific financial goal we want to achieve. This will help us to justify the complete project and determine the resources we need. Next, we need to derive a machine learning project, a machine learning problem. So we can solve this with appropriate algorithms and techniques. Once you have a clear understanding of the problem, we need to gather the requirements. This includes finding out what data is available, what data we need to collect, where is it, how to access it, who is the data producer. And with these requirements in hand, we can design a solution architecture and select the starting technologies that we are going to use in the complete project. This includes the designing the hardware and the software platforms that we will use. And finally, we please go to the next slide. And finally, we need to do an initial data analysis, to know how the data is, and also to make an initial sketch of the features. So the next phase is the data engineering. So we need to acquire the data required for the ML model. So first, we need to determine like the transformation and the cleaning and the feature engineer's rules. This is a crucial step because it will help us to make the data suitable for the machine learning project. These rules should be easy to iterate with and in order to adjust them based on the feedback of the next stages. Next, we need to create a feature engineering pipeline. This includes connecting from the raw data, extracting the data, transforming, cleaning it, and performing feature engineering. This stage require their own CI/CD infrastructure and to ensure that the pipeline is robust. And finally, we need to save them in a feature storage system. This is important because it allows us to make a version of the features and store them for later use. The next phase is the ML. In our ML lifecycle is the modeling phase. We focus on researching and creating a working ML model that meets the business requirements. This phase is very research-oriented and requires a continuous integration with the previous stage, like the feature engineering stage. We need to prepare and validate on that our data is suitable for and consumable for the model. Now, when it comes to integrate the training and validation, we need to iterate over multiple algorithms to find the best performing algorithm. The measure of success we define in the scoping phase is our guidance metric. So we need to also include like the requirements and the constraints to avoid every bias in our model selection. For this stage is crucial the reproducibility of our experiments. Because in a given moment, for example, you want to know how you acquire these results. So you will need how the model was built, what were the results, what data was used, what the training process looks like. So to answer all of these questions, we should have an ML metadata storage. The outputs of this stage are the selected ML model and the ML workflow pipeline code. Both of them are versioned and pushed to the storage repository. Our next stage is the deployment. This stage is all about putting the selected ML model in a production and making predictions in real world data. This stage is used with the ML pipeline that we create in the previous stage. The data extraction, validation, preparation remains the same as in the modeling phase, in the previous phase. And also once it's trained and validated with the new data. Once the model is validated, it is pushed to the model registry, and the production-ready model then goes like to the model serving component, where it is ready to make predictions on our new data. These components determine how the model will be exposed like to the end users. All of these little phases in this big phase are automatic. So we need an orchestrator to manage all the workflow and the pipeline infrastructure. The use of an ML metadata storage and a model registry is also important, as it provides a central repository for all the artifacts generated during this phase. Finally, the model serving component is responsible of making predictions and is connected to the model monitoring system. This final step is very, very important because is the component that will monitoring the quality of our ML project. So there are a lot of components that must be monitored in this stage. This includes the model performance, the data quality, and there are also other triggers for our retraining to retrain the model. For example, the time-based triggers, maybe some algorithm updates, and also a feedback from different stakeholders. Now you have a general idea of the most common steps in a machine learning project. Let's see some specific use cases.
All right, perfect. So yeah, the idea was to keep this all steps, stages, phases in mind, and let us show you some use cases that we found out during our different projects. So on the first side, let's say we consider this cost reduction for deployments consume a few times per day. So usually we're accustomed to have like models that eventually have a lot of throughput or have a lot of requests per second per day. So what if I'm trying to optimize for cost and I have a model that doesn't get that many of the calls? So for this use case, we can also say, hey, this is totally about deployment, but I don't need maybe the full scope, or I just need to use different tools. In this case, the main stage impacted, of course, is the ML deployment. The tech stack that we use for this specific use case was mainly about AWS, ECS, ECR, Lambda, and S3 buckets, and the team involved. And this is very important. We're going to mention some of the people involved in these projects and use cases. In this case, we're pure MLEs working for both backend and ML engineering pieces of this use case. Another use case we can show you about MLOps is this web scrapper from scratch, mainly for data gathering, model iterations, and model deployment. So as the name says, in this case, we're not only focusing on deployment, how we can make it faster or more cost effective. In this case, is how I iterate through the model. So in this case, data acquisitions and preparations is very crucial and critical. Model experiments and model deployments. The tech stack actually used a bit of, let's use some Lambda functions, which are these serverless functions that we can use to make requests, but also Postman, which is to make requests to APIs defined, and Label Studio that helps us to the whole labeling for the model. And in this case, the team involved in this project about these specific stages were all ML researchers. Another use case is a feature store definition and model training on top of it. So the idea of a feature store is to have a centralized location, as Lisa mentioned, to hold the features, the metadata, everything related to the features for the model. So we can have like a centralized place for them. In this case, the main stages applied for this one was data acquisition and preparation. Of course, we're talking about features, and then also ML experiments and training as well. The tech stack for this one, we use dbt to manage our SQL queries. We use MLflow, which is one of the most useful and known tools out there about MLOps, Scikit-learn, Snowflake, Airflow for orchestrating these tasks. And the team involved was also about ML research. So let's keep in mind that so far, even though we're talking about MLOps applications, it's been about ML researchers and MLE engineers, machine learning pure engineers. Another use case are microservices with multiple ML models that can be swapped in real time. And eventually during the nights, I can retrain. So this is another typical that we have models out there. We have different models for different services, and I need to plug in, plug out different models to do different things. Data engineering, ML deployment, and operations in general are the main stages. Some tech stack involves, again, some AWS services such as EC2, ECS, Aurora, and Lambda. And on the other side, we use Spark and GitHub Actions to manage the workflow of it. And the team involved in this case is a bit different. We have MLEs for model deployment and model serving. We have software engineers for the backend, and we have SREs or software reliability engineers for the infrastructure side, and CI/CD managed auto pipelines. Another use case, ML tracking for metrics and artifacts for vision models. In this case, it's about, I have a model, I develop a new version of it, I did something different, but I need to know what my tracing and experiments look like before. So in this case, ML tracking and ML deployment, also main stages about the ones, the big picture we show. In this case, MLflow, Spark, and Databricks along with all the services. And the team involved was mainly MLEs. That's the. In this other and last use case, I think this is the last one, end-to-end feature-based recommender system. So if you imagine, this is not just, okay, let's focus on the business scoping of the project and let's see what's the best out of it. It's actually mainly all stages up to monitoring. What happens once the model is not in production? So ML design, data engineering, ML development and deployment, and model monitoring. This is the last step. So it involves like mainly most of that. The tech stack uses a lot of most specific cases such as GeoPandas, which is Pandas library for geolocation, Mapbox, Lambda, Fargate, most of them AWS resources such as Terraform and GitHub Actions to manage the infrastructure of the system. In this case, the team involved was product managers to scope the business idea for it. Full stack engineering for the main thing that the user looks at when he looks into the service. And then again, machine learning engineers doing the rest of it. So you can have a sense of what are the kind of teams we usually have on these things. Let's talk a bit about then the principles and considerations that we have to keep in mind when we're dealing about MLOps. So I think, yeah.
Okay, so MLOps can be conceived as both organizational and technology problem. This means that we don't only require a good organization in our teams, but also require a good selection of a technology and practices that tackle like a specific requirements. So, for example, one principle that every team could implement is the CI/CD automation. It provides like fast feedback to all the developers and all the team, and this will help to debug easily across the complete pipeline and across all teams. Other principle is the continuous ML training and testing. Most of the time, the retraining is based on a feedback loop, or maybe that feedback loop comes from our monitoring component. So this includes, so please include the monitoring component as part of your pipeline in your project, because deployment is not the last stage. We need to include the periodic assessment of data, our code, and also the infrastructure to detect potential errors, and to take into account some things that maybe you previously don't take. And also use manual inspection. It's not only all about automation, everything. You could also do manual inspection. The next one is start small. So this is basically create something very easy. Don't try to use like the state-of-the-art algorithm when maybe a simple model can resolve the problem. First, create a baseline model and then start to upgrade your model. The next one is, okay, this is something that you started to notice, is that when companies are small, they maybe want only one person that could do the complete pipeline, maybe an ML engineer. But after the company starts to grow and the project starts to grow, maybe they want a dedicated person with for the specific stages. So maybe at the beginning, you could help, like if you are the person that are conducting the complete project, use, for example, the workflow orchestrator to coordinate different tasks and to take into account the relationships between different stages. Also, as your team grows, the collaboration is like the key to the success of the project, and also the feedback loops, because this is all about communication across your teams, like your learning in the different stages. And next one is about
this talk is being very interesting. I want to remind everybody that in about 10 minutes we will have the Q&A sessions. So I want to encourage everybody that if you have any questions, you can freely ask them on the Zoom Q&A, on the Zoom chat, or on the Huba Q&A, and we will answer them at the end. All right, carry on, please.
Yeah. So the other one is that the lack of minimum standards for model development and experimentation could give like very different problems in different stages. So basically here, the principle is the reproducibility. You want to reproduce all your experiments, maybe versioning in all of them, and use maybe ML metadata storage. The next one. Yeah.
All right. So let me talk a bit about other considerations. So there is this piece that companies usually suffer from understanding the same raw data. The image, we wanted to put it in there because for me, I'm machine learning number one, and you said it's machine learning number two. We have like different understanding, and we think the data means something different if we create our own feature engineering on top of it. So the idea is that we can standardize the features, calculations, and how the models use those definitions. That is another consideration to keep in mind, and also to focus on obtaining and granting access to complete data. This seems trivial, maybe for some of you, if your companies like have this from scratch, but I can assure you, we've seen use cases and we have knowledge of teams that are getting into a company that is migrating resources or data or whatever. And eventually some people do not have access to the full complete thing. So they need to train models on a small piece of the data, or they need to use something to like simulate how the data looks like before getting into real data. So this is actually crucial for MLOps. So in this case, the principle is about data management. It's about, let's make sure all of us have the same data and it is being managed correctly in terms of labeling and feature management. Another consideration to keep in mind is that successful MLOps, and we're talking about the whole life cycle, is not responsibility of one single person on the team. It's just a matter of a team effort in terms of different roles and interaction between them. Those can be included, and as we saw in the use cases, business subject matter experts, data engineers, data scientists, machine learning engineers, software engineers, DevOps, analysts, any other role that at some point interacts with the machine learning model is, if we think about it as a product, is involved into the main idea of the value and successful delivery of the machine learning. So in this case, the principle, it's inside delivery. And the ML value, as we mentioned, depends on the whole team, not just one person. That is also to keep in mind about MLOps. So before we jump into the last section and the idea of this talk and the conclusion we're trying to get into everyone's mind right now is there are machine learning packages. There are eventually DevOps packages. That is well defined. We have libraries that can do whatever we need. And when we talk about MLOps packages, that's when the trick fails, because there is no MLOps packages that one fits everyone. If I'm a data scientist and I'm developing something, I know that eventually the packages I have on the language I'm using are going to eventually solve my problem. I need to tune something. I need to import something else. But essentially, the main tools are the same. From an MLOps perspective, and as we saw in the use cases and all the stages, there is not such thing as I'm giving you the full MLOps package to do whatever you need to do. So that's to keep in mind. So with this, let's jump into the last section about the MLOps role. What does it mean? And I know, and Whitley said we did this on purpose to guide your mind a bit into, for different companies, the definition of MLOps changes. And I'm sure you already know. So if you're seeing out there positions that eventually they're looking for an MLOps engineer, as it seems, maybe you're falling into the first piece right here. Either they're looking for a DevOps with knowledge about ML, either they're looking for a machine learning engineer with some knowledge about software in general, or they're looking for a software engineer that essentially had done some projects about ML. That is the first case scenario, and that is usually what happens when they're dealing about MLOps. Now, if you're on a second stage of, maybe I don't need one specific person, I need a team. I need someone focused on something, and I need someone else focused on something different. Maybe they're looking for machine learning engineers and data engineers to assemble the different stages, for example. Or instead, if they have a huge team, then they're looking for engineers and scientists in general, as we mentioned, MLEs, data engineers, data scientists, DevOps, infra people, to assemble the MLOps team. So with this in mind, the MLOps role is still to be defined. That's like one of the pieces and main conclusions that we want to make sure everyone understands. Is like, if you see a specific job requirement looking, hey, I'm looking for an MLOps engineer, well, we encourage you to look and deep dive into the requirements, saying, oh, they're looking for someone that actually focus on traceability and tracking. Okay, let's focus and let's look what those tools actually mean. So in this case, we indeed come up, and we took it from Google Cloud, this is a specific reference, but I think it defines what we think it's an MLOps. So an MLOps is an ML engineering culture, and we want to change that because essentially it was born naturally on the companies that had needs about MLOps. Hey, I have a model, doesn't work for some reason in production or during the development or whatever. Well, actually, let's change our company culture and let's involve MLOps into it. So it's an ML engineering culture and practice that aims to unify ML system development, the usual development, with ML system operations, which is this ops. That's why we get this ML ops idea. Therefore, an MLOps engineer is the advocate for automation and monitoring all of the steps into the ML system lifecycle. As it says, it's an advocate, it's a person that promotes, it's a person that says, hey, I want to do it better, I need to automate better, but it's not a role defined worldwide that we can all agree about what it means. So with that in mind, I hope this was very interesting and useful. We have some closing remarks. We're still defining the role. And we as Factor, we don't have the final answer. Whatever you are all from your companies, I'm sure you all don't have the final answer neither. There is a community arising worldwide about what this means. But again, it depends on what we think the role in my company needs. We're all active players in this MLOps spectrum. There are different stages, different proposals, different things we can touch. And I'm sure each one of us can actively work on them. We all need MLOps, but we don't, how deep? Actually, that's what depends on us. If I'm a company, a startup with 5 people, I'm not going to assemble an MLOps team of 5 other ones because I'm sure I don't need all the complexity that implies. But maybe I need a person to manually do something that is crucial for my startup. And these days, the problem isn't to develop model X or model Y. I can assure you that most of the models are already developed. The problem is how I can maintain those models. That's why MLOps it was not a thing early days, but it's now a thing now that everyone is using models out there, but I need to maintain them and use them for my own benefit in my company, within my team. With that in mind, we thank you all. I hope this was, again, an interesting presentation about what's the current state of what MLOps means. And yeah, I think it's time for questions and answers. So we'll give the mic. Well, I'm not sure. I don't think you can all speak, but let's go.
So thank you very much, David and Lisette, for this talk. Now we are going to proceed with the questions. We are going to go through the questions in Huva, then the questions on the Q&A on Zoom, and then any questions that there might be on the Zoom chat. So in Huva, we have a question that says, how can queues be used in an MLOps pipeline to manage and prioritize tasks related to serving a machine learning model? Can you give an example on how you have implemented queues to ensure efficient and effective processing of tasks in a large-scale production environment?
Do you want to take that one, Seth? Do you want me to take it?
Take it.
Okay. In my understanding, when we're dealing with queues, it's like for some reason we need to prioritize. That happens on any any team that is developing a software. We need to task. We have some tasks that are more important than other ones. Happens the same to machine learning. And I want you all to keep in mind that for me, in my understanding, and this is my personal opinion, we can all have opinions, but in my case, I think machine learning itself is a product, and I need to give that product to someone. At the end, what I'm trying to develop is something that someone can use. And in that sense, if a product needs to prioritize something on the model serving side, which is what this question is about, is like, what is the serving final audience and what are the requirements on the serving? I need to make sure. Is it serving? I'm putting serving on top of the cost that eventually putting a very reliable and sustainable system is going to put in place. If the cost is not if the cost is not a variable I can consider in mind, well, maybe I don't need to prioritize the main ideas of how can I make sure my model delivers the value. But if I'm dealing with, okay, it's not just about, cost effective, or it's not just dealing about what are the tasks I can put on it, but it's about, let's see what are the main things I can consider so my serving makes sense to the people that are using it. I guess the answer depends totally on the company and what are the kind of things you do need to consider to make sure the model makes sense. And this goes back to the principle of start simple, because in my experience, when we have different tasks, most of them are trying to address issues that are not even appearing on my system. It's like, I would like to have something on my serving side, because, for example, what happens is if 1 million people comes into the same second, Well, yeah, that's a possibility, but it's a 99% possible probability that it's not going to happen. So that is not a problem I do have right now. That can lead the thinking what to prioritize and what to not. But of course, if I'm serving a model that is eventually classifying between dogs and cats, I need to make sure that the images do not have any problem as they come through. So that is the kind of things I will prioritize. I hope that can lead the thinking and and actually can and help us to understand the question.
Thank you, David. Thank you, Sebastian, for asking that question. And we have a question from Darwin. Is it a requirement nowadays for an ML engineer to have knowledge and back and front end?
Okay,
Go ahead.
I could handle it. And it's not a requirement itself to be a software engineer right now. It's mostly right now, it's like a merge between different fields. And how do you know like the complete pipeline to do a machine learning project? So if you know how to put your ML project to your ML model in a production environment, I think in most cases it is enough. But of course, it would highly depend on the company, because if the company have like already their software engineer team and also the data science team, maybe you need to know in which of those teams you will be. No, but if the company doesn't have those teams like divided and maybe just have a single team for the entire project, maybe you have to know like some of the technologies used not only in data science part or ML part, but also in the software engineer part.
All right. Thank you, Lisette, for answering that question. Finally, we have a question from Laura Lopez. What are the most important tools that an MLOps engineer should know?
I can take that one, and I can share a very small experience I had in another talk I joined about MLOps. And there was these two guys talking about MLOps, doesn't matter who they are. But my question to them eventually on the seminar was like, hey, there are tons of different technologies out there about MLOps. Every day you log into LinkedIn or any other scenario that you read news about, and you're going to see a new MLOps tool arising. So how can we filter out the ones that make sense, which from the ones that are just at some point useless for the rest of people? And their answer was always about focus on your problems. And I'm going back into this principle in terms of, if I do have a problem about ML tracking, for some reason I have a team, or we have a team of 10 data scientists, and each one of them has its own Jupyter notebook, and each one of them has its own different features and whatever. And I want to replicate what was the model I developed 2 months ago, and I'm unable to. Maybe model tracking for me makes sense, and I will go ahead and look for MLflow, for example. MLflow for tracking is like the way to go these days. But maybe it's not the issue for startup number 2 that only has one data scientist working on all the models, and this data scientist is not using MLflow, but it's logging the different artifacts and different metadata into a logging system. But that team actually has 1 million users, and each one of those users have different needs on the serving side. So maybe the technology I will look, it's almost on the serving side. So with that in mind, I'm not sure if there is one technology that everyone should know about MLOps. Again, it depends on the team. But certainly, for example, MLflow open source is a very good used in the industry. Also some orchestrators for CI/CD pipelines, such as GitHub Actions, Jenkins, any other ones you can imagine for orchestrating and automating things. Airflow, I think Airflow, it was born for data engineers to manage their workflows, but at some point is gaining terrain and gaining tracking into ML, because we can orchestrate our own developing there. And there is another one, which is I'm going to give it as a bonus, but in terms of orchestrating containers and microservices, there are some other things such as Docker Compose or Kubernetes that are very used. A machine learning engineer it's not a restriction or should not know that in depth, but if you at least understand how it works, it will give you a very good insight about what you can do with your models in terms of orchestrating the final deployment, for example. And on top of Kubernetes, there are some add-ons that are built, such as Kubeflow. Kubeflow is also to manage automated pipelines in ML. And yeah, I think, again, this depends. Also the ones in the cloud, AWS has its own service. SageMaker has a lot of MLOps services. GCP has its own. Vertex AI. Azure has its own. So maybe cloud services can be another thing to know.
Perfect. Great. Thank you, David, for answering that. Finally, we have Jose Niño's question. How easy is it to transition from a data science position to a machine learning engineer? Are skills a lot different?
I will answer this. I think right now is more easily to pass from software engineers background to know like about ML or data science things. But of course, the reverse is something that you could do easily also. Because if you comes from a data science background, what is happening is that you have like a research-oriented view of the things, and you have to acquire the project view of the machine learning stuff. So you need to start to implement some practices that are very, very useful of DevOps and the software engineer that makes the machine learning model like suitable to a production environment. So yes, of course, it's something that you could do. Start with the principles and the use the principles that use the DevOps and software engineers to create like the background you need for the to create the machine learning product.
All right, thank you, Lisa. Those were the questions from Hugo, and now we are going to go with the questions from the Zoom Q&A. Please be a little bit more succinct because we are kind of running out of time. So Sebastián Rojo asks, what are the most important considerations for scaling large machine learning models in a production environment? And what strategies have you found to be effective in overcoming challenges such as model performance, computational resources, and data security?
All right. Maybe on that one, scaling large machine learning models, which is mostly out there, most of them, in a production environment. I think that involves having in advance and being sure what are the kind of requirements I need to have in production. With that in mind, there are different strategies that we can essentially, in terms of, for example, vertical and horizontal scaling. If I have a model that consumes a lot of resources by itself, but for some reason cannot be split, I need a single node in a cluster environment and deploying that actually needs tons of different sources. But if I'm considering a model that essentially, for example, like has a tons of different little requests that can make it in a single package very consuming, well, maybe let's split them into replicas and let's make sure that each one of them actually shares a bit of those, which makes sense. And so that is one strategy to focus on, can I scale it vertically or horizontally? And in terms of model performance, computational resources, and data security, I think on model performance, the trick is to put a model monitoring in place on top of it. If you're using cloud services, most of the cloud services already come with any kind of performance monitoring you can see on them, either for what are the requests, what is the latency, how much time they're taking, but also you can create your own model performance in terms of the metrics of your model. What is my accuracy? What is my distributions and everything else like that? So that is also important to keep in mind. And for computational resources, this scaling piece maybe affects that and also gets into that. And for data security, I have to admit I'm maybe not the most expert person on data security, but I guess even if you follow regular security ideas that comes from DevOps and infrastructure environments, you will be fine. that because we're taking the same ideas from it, but maybe there are some other things and services you can put to satisfy those.
Right. Thank you, David. That was a great answer. And now, finally, we have Juan Vaqueros. A question. I have been working as a data engineer and as a data scientist. I want to shift to MLE world. How do you recommend to do it? How do you end up working as an MLE?
Okay, I think you have like the perfect background to be an MLE, because if you are a software engineer and also have the background with data science, you have like the merge of the two things, the two required things. I think it's important to have in mind like the principles, like the things that are required for a machine learning pipeline, like the principles that we talk about, like reproducibility, the one about the continuous training, continuous retraining your model, but also the monitoring phase is very important to check your quality in every stage. But yeah, of course, you have already like the two sides of the coin.
Yeah, just to add that last piece that Lisa mentioned, totally agree that if you already are a data scientist and you're trying to switch to MLE, you're like in the perfect mix, because you know the backend, you know how the things work in the engineering side, but also with the scientific knowledge of how the model works in mathematics and statistics, you can create your metrics and performance and everything that will make sense to monitor and to deploy and to keep in mind. So yeah, I guess it's very recommended.
All right, those were all the questions we had. Thank you again, David and Lisette, for your time. It has been a pleasure to learn from you, and thank you to everyone who attended.